In this video, I'll demonstrate how to add one of our O210-BC Remote I/O bus couplers to a Machine Control Studio software project. I'll demonstrate how to use the graphical cyclic link editor in Machine Control Studio software to create RTMoE cyclic data links between an MCi210 machine control module and the coupler. How to access and use digital inputs and outputs as part of a Machine Control Studio program POU. So if you're ready, let's get started. The communication method used to access the bus coupler from the MCi210 module is our RTMoE, or Real-Time Motion over Ethernet communication protocol. Using this protocol, the MCi210 machine control module can transfer up to 128 bytes of data in 1 millisecond, with up to 16 I/O modules attached to the bus coupler. While an update of 1 millisecond is very good performance, it is recommended that any mission-critical I/O, such as home sensors or position capture, which we call freeze inputs, be wired directly to the host drive for best results. In the video that follows, I'll be demonstrating the steps necessary to create the cyclic data links between the bus coupler and the MCi210. There will be 2 links created. One link will be created to read data from the bus coupler, and the other link will be created to write data to the bus coupler. Each link will contain 2 parameters. The read link will read the bus coupler's status word and the state of the digital inputs I'm using for this demonstration. And the write link will be used to write the bus coupler's control word, which is used to reset the bus coupler, and also to turn on the digital outputs I'm using for this demonstration. These links utilize PLC registers _R, which is menu 72, and _S, which is menu 73. Therefore, you should avoid creating user variables in these 2 menus. Before I open Machine Control Studio software, let's have a look at how I have my demonstrator equipment configured. I'm using a Digitax HD M750 with an MCi210 machine control module mounted into slot number 2. I've connected my Ethernet patch cable to port number 1 on the MCi210 module. I've connected another patch cable from port 2 on the MCi210 module to port 1 on the O210-BC bus coupler. I have a model number GT-1238 8-point digital input module and a model number GT-2328 8-point digital output module mounted to my bus coupler. I have a simple switch connected to digital input 0, and I've wired digital output 0 to digital input 1. Now, let's have a look at Machine Control Studio. Okay, I'm going to open Machine Control Studio, and let's begin a new project. What I'm going to do with this first project is I'm going to create the cyclic links that are required to communicate back and forth between the MCi210 and the bus coupler using our RTMoE protocol. So I'll begin by choosing New Project from Network Scan. And here's our Device Explorer, looking for devices. And there they are. So here's my MCi210, which is 192.168.190, and my bus coupler right here. Now, if you have a look at the first video in this series, Getting Started with the Bus Coupler, there I show you how to use this tool to establish IP addresses. So I've already done that. So I'll just go ahead and click OK. And Machine Control Studio will build my project. And here it is. So I'm going to maximize this now. There we go, so we can see everything correctly. So there's my Digitax M750, which I'm not really concerned about right now. But here's my MCi210. And as you can see, the application for the device is in bold font. So that means that when I compile the application for the MCi210, it will be downloaded here and not to the onboard memory for the M750. And here's my bus coupler. So as I mentioned earlier, I have a GT1238 8-point digital input and a GT2328 8-point digital output. So the first thing I'm going to do is I'm going to start the graphical link editor right here. Here's the tool that we use to form the links. So I'm going to begin in the devices section. And the first thing I'm going to do is choose the devices for which I'm going to create links. Well, I'm not going to create links for the Digitex M750, so I'll uncheck that. But I am going to create links between these two devices. So next, I'll just go right to the mappings. And here is where we're going to form the two links. So to do that, it's quite simple. The first thing I'll do is just click and hold, and then I'm going to drag this line down. You see that? To the bus coupler to form the first link. So this is general cyclic data. This is just going to be I/O, inputs and outputs, not synchronized motion. So that is correct. I could change the transmit rate, but reading and writing I/O at a rate of 10 milliseconds is sufficient for what I'm going to do. And as I mentioned earlier in this video, anything mission critical like position capture and home sensors and things like that, those type of inputs should be wired directly to the drive. So to create that first link, I'll just click Create. And there we go. So now I have a link going from the MCi210 to the bus coupler. And before I get off of this screen here are the two links that will be transmitted from the MCi210 to the bus coupler. And this is important. You see the control word. The control word is used to reset the bus coupler in the event that it trips. And I'll demonstrate that. I'll show you how to reset it. And then the second one is the actual 8-point digital outputs that'll be coming from the 2328, or well, coming to the 2328. I'll be writing from the MCi210 to the bus coupler outputs. So we're going to be using these here in a little bit. Now I'm going to form my second link, and that's going to be between the bus coupler. So I'll click and drag, there's my line, back to the MCi210. And I'll leave the transmit rate alone and click Create. Now the two parameters that I'll be sending from the bus coupler to the MCi210 is the status word. And I'll show you how to use that, and the state of the digital inputs. So there are my two links. Now, let's download those. So I'll click Download. Now what I'm looking for, if everything works correctly, you'll see a dialog, this one, that comes up and says they're both green, so they were both valid and downloaded. So I'll close that. Now let's go back to mappings. This is how you check to make sure that everything is working. And if you see up here, it says online monitoring. It's off right now. So I'm going to turn it on. There we go. So this green arrow indicates that I'm currently looking at the link from the bus coupler back to the MCi210. And it is green and it is working. Now let's go look at the other one. So I'll click here. And it too is green and working. So the next thing I'm going to do is I'm going to create a simple PLC program that will demonstrate how to actually utilize these inputs and outputs as part of your project. Now that we've formed the cyclic links for the communication between the bus coupler and the 210. Let's focus on the application. So here in the MCi210, I have an application, and that application has two POUs in it, a freewheeling and a position POU of type program. Now, I could use the freewheeling POU as it is. This is the text editor here, and while that would work just fine, I think it's easier for digital I/O to use ladder diagram. It's more visual and you can actually see what's on and what's off. It's a little more presentable. So what I'm going to do before we go any further is I'm going to delete this POU like so, and I'm going to add another POU. So to do that, I'll right click on the application, add object, POU. So I'm going to name this POU digital _IO, and it is going to be of type program, and I'm going to write it in ladder, just like that. So I'll click open. So here is the ladder editor, which I'm going to be using in a moment. But before I do that, and since I have deleted the freewheeling POU, what I need to do now is go and assign this new POU to the freewheeling task. So I'm going to double click on the task. And as you can see, it's going to try to run a POU called freewheeling on this task. Well, we don't have that any longer. So I'm going to remove that POU, and I'm going to add the one we just created. So here's the input assistant. We're going to be using this quite a bit. And if I expand application, here is my digital I/O POU. That's what I want to run on the freewheeling task. All right, so now that we've got that housekeeping out of the way, let's go and build a simple program here. Now, the first thing I'm going to do is show you how to use the status word and the control word. So here's my first network. And what I'm going to do is, if you were to look at the user guide for the O210 bus coupler, you would see a section that explains how the status word and the control word work. The status word is a bit mapped word. It's a byte, actually. And those 4 bits are going to determine the state of the bus coupler. Well, when it comes right down to it, the 3rd and 1st bits, if those are set, then the bus coupler is in an operational state. And that represents a decimal number 5. So what I'm going to do in my first rung is I'm going to check to make sure that the status word is equal to 5. And if it's not equal to 5, then I need to reset the bus coupler. So to get started, I'm going to come up and I'm going to add a box. So I'll click in my toolbox over here that I've got pinned back. I'll just unpin that. I think we have enough screen real estate here. So I'm going to grab this box and I'm going to drop it right there. So the first thing I'm going to do is define what kind of box is this. So I'm going to use the input assistant to do that. So I'll click the ellipse button. Here's the input assistant. And here are the categories for inputs. Well, what I'm looking for is not equal, right? So it's not in a module call. It's going to be a keyword. And they're in alphabetical order. So if I move down to the N area, I see NE. That is not equal. So I'll double click that, like so, and hit enter. And you'll see the symbol for not equal. So I'm going to say now, if the status word is not equal to decimal 5, then I'm going to add a coil that says the bus coupler is tripped. So I'll click here, and let's add our first condition. So I'll open the input assistant. Now I'm going to be looking at a variable category. And specifically, the variable I'm looking for is found here in the application. So if I expand that, you see this auto code folder. Well, that was created automatically by Machine Control Studio the first time it found the bus coupler. So what it did, if I expand auto code now, there is the bus coupler. And if I expand it again, here are all of the elements relative to my bus coupler. I've got a control word, I've got a status word, here are my 8 digital inputs, here are my 8 digital outputs, and we're going to be using these, but here they are. Nice and neat, very simple. So I'm going to get back to what I was doing. I'm going to check the status word. So I'll double click there and hit enter. So it says if the status word is not equal to, and I'll say add a constant, decimal 5, meaning it's not in an operable state, and I'll click at this input point so that I can add a coil, and my coil is going to be, I'll just create a variable here, station 1 trip. Now my application does not know what that variable is, so I'm just going to very simply leave it as default here and say that that's a Boolean data type, because it is, and I'll just click OK. So there we go. So this is going to catch to make sure that the bus coupler is in operational state, and if it's not, it's going to turn on my station 1 trip. Now let's add another network. I'll just right click over here, insert network below. Here I'm going to use the station 1 trip as a contact. So I'll click there. And this time I could use Input Assistant, of course, but I want to show you the autocomplete. So if I start typing, see, there it is, station 1 trip, double click, hit enter, whatever. That's what I want. So station 1 trip is true. Now I'm going to add another box. But this box, you'll notice this box doesn't have an enable or an enable out. This box requires an enable. So, or I'm going to add a box that requires an enable so I can use that as the enabling feature. So I'll click here, and then I'll choose box with ENO, just like that. Drag it over and drop it on the little green rectangle or diamond right there. You see that? Now this box, in order to reset a trip, I must write a 1 to the control word. In fact, that's all you can do with the control word as of today. So the type of box I want here is a move. Now I can type that, but I'll show you using the Input Assistant. Once again, that's going to be a keyword category, move. And I'll just come down here. There it is, move. So I'm going to just move a constant 1 to, and I'll use the Input Assistant, back to variables again, back to application, auto code, bus coupler, control word. So I want to write a 1 to the control word to reset the trip. So that's pretty simplistic, but hopefully you see how to read the status word and then how to also reset the bus coupler using the control word. Now let's go ahead and add a couple more networks here just to show you how to utilize the digital inputs and outputs themselves. So I'm going to add another network below, and I'm just going to come up and use an input first. So I'll come up and add a contact. And as I mentioned earlier in this video, I just have a simple switch connected to channel 0 or input 0. So what I'm going to do to check the state is I'm going to expand this box so you can see it. There's my inputs. And all I need to do to check the state of channel 0 is just double click, enter. So when this is on, I'm going to add a coil, and I'm just going to very simply say in 0 active. And once again, when I do that, Machine Control Studio does not know anything about that variable. So it opens the auto declare editor, and here it is. It's a Boolean input, so I click OK. All right, now let's add one more rung to write to an output. So I'll insert a network below. Now here, what I'm going to do is I'm going to use a contact again, but I'm just going to create a variable that I can write to myself. So I'll click there, and I'll just create my own variable called activate out 0. There we go. Input assistant, or the auto declare editor again. I'll click OK. Now let's add the coil, and this will actually be physical output 0. So I'll click here, input assistant, there's my bus coupler. Now instead of the inputs, I want to use an output 2328 channel 0 right there. That's what I'm going to write to. So there we have it. Very simple. 4 networks. Let's build this, check for errors. Yes. Okay, no errors. You can see, there we go. Sending it down. Now let's test it. Currently, the application is stopped. So I'm going to come up here and start it. All right, well, let's see. Well, you can see the status word is 5, so it's not tripped. So there's nothing happening there. So let me turn on my switch now. There we go. You can see it's reading channel 0. You can also see up on top in my variable declaration area that is coming on and off. And now, by the same token, let's turn on our output right here. So I'm going to come up here, double click there to change prepared value to true, and then FN or Control F7 will write that, and my output is on. So that's a very simple explanation or example of how to utilize the O210 bus coupler digital inputs and outputs with Machine Control Studio and an MCi210. Using the O210-BC bus coupler with an MCi210 machine control module and our Machine Control Studio software is easy. Begin by using the graphical cyclic link editor within Machine Control Studio to form the RTMoE links between the bus coupler and the MCi210. And once you've downloaded the links to the MCi210, all of the data points for the individual modules connected to the bus coupler are accessible for use in your application. Thank you for watching, and more importantly, thank you for choosing Control Techniques.